Hey guys, so here's the notes for 7.4 day 1. We're going to be talking about rewriting and evaluating logs. Now first, let's talk about logarithms. What are they? Well, they are going to be the inverse. Remember we talked about inverse functions? They are the inverse of exponentials, and they look like this. Okay, well, we'll get to that. Okay, first of all, well, let's say we want to figure out the exponent, meaning that if we think about 2 to what power gives us 4. Well, we know what that is. That's going to be 2. Like, we can calculate that. What about 2 to what power gives us 8? Well, that's going to be 3. 2 to the third gives us 8. But what about 2 to the what power give us 6? Do we know exactly that? No. Okay, that's where you would have to do a plug and chug and try to figure that out. This is where logarithms come into hand. When we do not know exactly the power to give us, we use logarithms to find that out, okay? So this is what a logarithm looks like. So we have log base b of y equals x. And you can see that's what it's read. So log base b of y, and I'm going to say equals x, okay? So I will be using that quite a bit, so make sure you understand and know that vocabulary there. Okay, so let's talk about how can we rewrite from logarithm to exponential form and vice versa. Okay, so exponential form, we're going to have that as b to the x equals y. Now, we can rewrite that as log base b of y equals x. So b is going to be our base. Okay, and that's the same thing here. B is our base. X is going to be the exponent. And y is going to be our answer. Okay, so if we look at the first problem, notice we can rewrite it in different forms. So we have the exponential form of 2 to the third equals 8. We can rewrite this in logarithmic form. Well, here 2 is our base. The 3 is our exponent. And then our 8, that is our answer. Okay? Same thing for 4 to the 0 power equals 1. Well, notice that for the exponent, 4 is our base. That's the same for the logarithm. 0 is our exponent. So that's our x. And 1 is the answer. So knowing this formula and knowing how to switch it will make it very easy when we need to do this. Okay, so let's try 12 to the first equals 12. So we're going to do this one together. So we need to figure out what is the base. Well, the base on our exponent is 12. That is going to be the base on our logarithm. Now, notice here, when we look at logarithms, those numbers like 2, 4, and our 12, those are what we call subscripts. So they are going to be smaller than everything else, okay? So be careful on how you write this. It's going to have to be smaller. It's called a subscript. Okay, next we have our y value. That's our answer. So our y, if we look at the exponential form, is 12 as well. So we have log base 12 of 12. Then equal to our exponent. So our exponent here is 1. So we're going to have it equal to 1. So log base 12 of 12 equals 1. Okay, I would like you guys to go ahead and pause the video and try the next two. Okay, let's see what you got. So on our next one, 1/4 is the base. So I have log base 1/4. As I said, that 1/4 is called a subscript. It needs to be smaller than everything else you have. Now, we're going to do the y value, which is the answer. That's going to be 4. When we look at the exponential form. And then our exponent, -1, we said that equal to. Okay, on the next one, 2 to the x equals 6. 2 is our base, so we have log base 2. Our answer, which is y, That's going to be 6. And then we set it equal to our exponent, which in this case is x. So all I'm doing is I'm following the two different forms. So my b is the same thing as the b on the log. The x is the same thing as x on the log, and y is the same thing as y on the log. Okay, now let's switch that. So now we're going to go from logarithmic form to exponential. And so we do the same thing. So we have to identify the base. So let's look at log base 3 of 81 equals 4. Well, 3 is our base, so that's going to be the base on our exponential. Now, the 81, that's going to be our answer, but if equals to 4, 4 is our exponent. So that's 3 to the 4th, and then equal to my answer, which is 81. Now, the nice part is when we go from logarithmic to exponential form, well, we can check our answers. So if I do 3 to the 4th power, does that give me 81? Yes, it does. Okay? So whenever you do that, you can always check. Okay, I'm going to rewrite this so you guys can see that a little bit better. 3 to the 4th. There we go. Equals 81. Good. Okay, go ahead and pause the video and try the next two. So change it from logarithmic into exponential form. Okay, let's see what you got. So our base here on our log is 7. So I have 7. Then our exponent, which is x, is going to be 1. And then our answer is going to be 7. Well, let's check this. 7 to the 1st. Does that equal 7? Yes. So we did that correctly. Okay, let's try the next one. We have log base 1/2 of 32 equals -5. So our base here is 1/2. That's the base on the log, so that's going to be the base on our exponential. Then our exponent x is 5, or -5. And then that's equal to our answer, which is 32. Okay? And of course, if you plug this into your calculator, -1/2, or 1/2 to the -5th would give us 32. Okay, so I'm going to show that we went this way. And then we went this way. So you guys know. Makes sense. There you go. Go back. Okay, let's continue to do this with evaluating, okay? So with all of these, I want you guys to go ahead and set all of these equal to x, because that's what we're trying to find. We're trying to find the exponent, or the x. So what we need to do is we need to rewrite from log form into exponential. So remember how we do that. I'm going to do log base b of y equals x. And that'll be b to the x equals y. Okay? Okay. Okay, so with our log base 4 of 64 equals x, let's go ahead and rewrite that in exponential form. So we're trying to evaluate, we're trying to figure out what would x equals. So here, b, our base 4, that's going to be the base on our exponential, so 4. Then our exponent x, and then we have equals to 64. Now some of these are going to be a little bit easier, right? Well, let's think about it. 4 to what power gives us 64? Well, that's going to be 3. So this one you can kind of think in your head, what would that value be? So it's going to be 3, okay? And you can try, you can say 4 squared or 4/3. Plug it into your calculator and see what works. Okay, let's try the next one. We have log base 5 of 0.2 equals x. So 5 is my base. Once again, x is my exponent equals to the 0.2. Now this is kind of hard to figure out, right? Well, let's change that 0.2 into a fraction. What would the fraction be? Well, we would add 5 to the x equals 1/5. Okay. Now here's the thing, and this is using our exponent rules, which we did in our last unit, so let's make sure we remember those. Okay, whenever we either go from a whole number to a fraction, or vice versa, fraction to a whole number, our x is going to be negative, okay? Because remember, when we change it, we flip the fraction, or we kind of do the reciprocal, it becomes negative. So our exponent will be negative, Now we have to think, 5 to what power gives us the 5 in the denominator of this fraction? 1. So that means my x here is going to be -1. Okay, let's try the next one. We have log base 1/5 of 25 equals x. So I have 1/5, that's my base. X is going to be my exponent, equals the answer of 125. Okay, so now, once again, notice we are going from a fraction to a whole number. So is our exponent going to be positive or negative? It's going to be negative. Okay, now we have to think, 5 to what power gives us 125? Well, that's going to go ahead and be 3. And you can plug that. So if you're thinking, how do you know that? Well, just take 5. Take 5 to the first power. What does that give you? 5 to the second power. What does that give you? 5 to the third power. That gives you 125. So here, our x is going to be -3. Okay, let's try the last one. So we have log base 36 of 6 equals x. So our base is 36. We take it to the x power, right? Because that's our exponent, and equal to 6. Okay, now notice we have 2 whole numbers. So is our exponent going to be positive or negative? Positive. Okay, now notice we are going from a big to a small number though. So let's think about this. Probably some of you are thinking, well, this will be squared. But let's say we plug 36 squared into our calculator. What would that give us? Ooh, that's a large number. Well, let's try cubed. Okay, we're just getting larger. So those do not work. And we know our exponent has to be positive because we have 2 whole numbers. Well, what other numbers can we think about? What about fractions? So let's say we tried 36 and let's try to the 1/2 power. Oh, well, why does that work if we have 1/2? Well, this is once again going back to our radical notation. So let's say we have 36 to the 1/2. How can we rewrite this rational exponent in radical notation? Well, the 1/2 represents our radical, the root. So remember, 2 is the root, 1 is the power. So this is saying square root of 36. Well, what's the square root of 36? 6, okay? So if you're going from a large number to a small number, and they're both whole numbers, that means your answer has to be a fraction, okay? So we might want to write some of this stuff down to kind of help you out. So if you have a fraction and a whole number, then the exponent, which is going to be x, will be negative. And so that can either be you're going from a fraction to a whole number or a whole number to a fraction. Both ways, your exponent will be negative. If both are fractions or whole numbers, then the exponent, which is x, will be positive because you're not switching, meaning you're not doing any of the reciprocals, you're not flipping anything, okay? Okay, lastly, if both are whole numbers and the first value, or the value with the x, and the, we'll see, number with the exponent which is going to be x, is larger than the other number, then the exponent will be a fraction. Because otherwise, if you have your base, that's what I should have said, if your base is smaller than your answer, then of course you're going to have a whole number as your exponent. If your base is bigger than your answer, then your exponent is going to be a fraction. So if you need to pause the video and write this down, go ahead and do so. I'm going to go ahead and scroll up, so if you didn't get the top part, you can as well. So make sure you pause the video to get this stuff down. Okay, make sure you watch the next part. We're going to continue on with going from exponential and logarithm forms and even trying to figure out how to calculate this stuff in our calculator.